This is a detailed overview of the Chamfer Toolpath strategy. We're going to look at all of the options in the form and show the effects of the different settings you have on the toolpaths that you create. So let's just go to File, Close. So let's start by opening an existing file to help us demonstrate the Chamfer Toolpath. So from your project folder, we're going to open the Chamfer Toolpath Guide example1.crv and then go ahead and press open. So here we've got a series of vectors that we're going to use to demonstrate this toolpath. So let's switch over to the Toolpaths tab. And first and most importantly, we just want to check over our material setup. So here we're working with a thickness of 1/2 inch, XY position is in the lower left hand corner. I'm not concerned about the model position in the material because we aren't using any 3D data, so we'll ignore this for now. As Z0, we'll set that to the material surface, and then we want to check over the rapid Z gaps above the material, home start position are all safe and appropriate for your particular setup and machine. Once you're happy, you can go ahead and press OK. So the Chamfer toolpath can be found within the toolpath operations, the second row, and it's the last icon, the Chamfer toolpath. If we click on that, that will open up the Chamfer toolpath. Now, this toolpath allows you to easily create chamfers using V-bits or bullnose tools to create decorative edges, and is also a great way to create countersunk holes. So in order for us to create a chamfer, we need to select a vector or a series of vectors. So we're just going to look at one for now. So let's take a look at this vector here. So working from the top of the form going down, first off we must specify our cutting depth where we need to put in our start depth. Now the start depth is the depth at which the toolpath is calculated from. In our example, we want that at 0, which is at the top of my material. So we're going to leave that set to 0 there. Next up, we need to choose a tool. Or we could use a V-bit tool, a bullnose tool, or an engraving tool. For this example, we're going to look at using a V-bit, where we'll come and look at an example of creating a chamfer using a bullnose tool later on in the tutorial. So for now we can press select, which will open up the tool database, and then we can specify which V-bit we want to use. In this example, we're going to look at the 60° 1/4 inch V-bit. Next up, we need to specify our chamfer dimensions. So first up in the form is the angle. Now you'll notice that this box is actually greyed out, informing us that this value can't be changed, and that's because we are using a V-bit tool, and so the angle is actually being pulled from our tool, which is why we're seeing 30 degrees in here, because we are using a 60° tool. Now the only time that this option is available for us to edit is when we are using a bullnose tool, where we need to tell the software at which angle we want to cut our chamfer. But we'll look at an example of this later on in the tutorial. Next, we need to specify the width or the cut depth, where each value is calculated according to the other. For example, if I was adamant that I wanted my chamfer to have a total width of 1/4 inch, I could enter this value in, and you'll see that the cut depth has changed, where the software automatically calculates this based on the angle and the width entered. Another example could be that I wanted to machine this chamfer at the full depth of my material. So what I could do is I could enter in Z equals, which will pull out my material thickness for the cut depth, and the software has calculated what the width of the chamfer would be in this case. The last value in the form shows what the maximum cut depth will be, where this value is actually greyed out and is locked from editing, but it is there for information purposes. If you are using a V-bit tool, this value will always be exactly the same as the cut depth. However, if you are using a round tool, then this value will always be a little more than the cut depth specified, as it considers the fact that we are using a rounded tool, and so it has to cut a little deeper to achieve the requested width or cut depth that we enter within this form. But we'll look at an example of this later on in the tutorial. Next up, we need to specify the chamfer type. So we have two initial options to begin with: inside and outside. So you need to ask yourself, do you want the chamfer on the outside of the vector, or do you want the chamfer going on the inside of the vector? Let me choose whether the chamfer slopes down from the vector or slopes up from the vector. When switching between each of the options, there is a graphic to show what the chamfer will look like in relation to your vector. And in the 2D view, the software shows you how the chamfer will unfold when we machine this, where the point of the arrows indicate the deepest part of the cut. So for the purpose of this example, let's say we wanted to create a chamfer from the inside of this vector that slopes upwards. So we're going to use the slope upwards option. So it should look something like this. So the lowest part of the chamfer will actually lie on the vector here, where everything is going to be sloping up inside. So then we can give this toolpath a name. So we're just going to call this one chamfer 1, and then we could go ahead and press calculate. Okay, so we get a warning here telling us that we are going to be cutting all the way through our material. That's okay, I'm very well aware of that, so I'm just going to accept that. And then the software will automatically open up the preview toolpaths form along with the 3D view so we can see what is going on here. So let's take a look at this up the x-axis so we can see all of the different passes there. And if we just zoom in, we can kind of see the chamfer being created here. Okay, you can see it more so this side here. Right then, so we'll just put that back in Z, and then we'll go ahead and we'll just preview that toolpath. So we can see we do have a nice clean chamfer there. I'm happy with that. Now if we wanted to, we could actually cut this out. So we just put that back in Z, we can close out. And then if we just tile our windows, we can actually make use of the existing vector that we used to create the inside chamfer. And we can just put a profile pass on that. So let's use the profile toolpath, cutting it all the way through on the outside. We'll calculate that and then preview that. And you can see that that's done that there. Right then, let's close out here. So that's example number 1. So now let's run through another example where we may want to machine inside of the vector going downwards. So we're going to take this vector this time, and then we're going to go back into the Chamfer Toolpath. I'm going to use the exact same settings that we used before, except this time we're going inside and sloping downwards. Okay, so this icon shows that where the vector is, where the chamfer will be in relation to that vector. So it's going sloping down inside of the vector. And then if we go ahead and look in the 2D view, we can see that in respect to machining, the deepest part of the cut will be where the arrow heads are here. Right then, so again, we could give that a name. We'll just go with chamfer 2, and then we could go ahead and press calculate. Again, we're getting that warning. I'm happy with that, so we'll go ahead and press OK. And then we could go and preview that toolpath. So we can see that chamfer on the inside of that vector sloping downwards. And again, we've got a nice clean chamfer there. Now earlier I mentioned that the cut depth of your chamfer relates directly to the actual width of the chamfer and vice versa, all based on the actual angle. And so this is actually quite useful to know what the width of your chamfer is for when you want to, say, mill out excess area that we don't need inside of the chamfer here. So if we just double click to go back into the form, so that will show us all of the settings that we've used for that toolpath. We can actually take this width value here, and we can right click and use this option here to copy the value. whereby we can then offset this vector inwards by this amount, and that will create a vector for us that we can just completely pocket out to get rid of this excess material. So to do that, let's switch over to the drawing tab, and then we're going to use this vector here. We're going to offset that inwards, and then we're going to right click and then say paste to put that value in there. And we could go ahead and offset that, close out, switch back over to the Toolpaths tab, and then we can take that newly created offset vector and then go into the pocket toolpath, cut down at the same material thickness that we've got there, and then we could just go ahead and calculate that, preview that toolpath, and we can see that's cleared that away for us. Perfect. Right, so we can take that vector and actually delete that. We don't need that anymore. And we can close out of the preview toolpaths form. So let's now take a look at some other examples where there could be a case that we don't have a V-bit tool to match the angle that we want to machine the chamfer. This is where we would use a bullnose tool instead. So let's go ahead and we'll select this vector this time, and then we'll go over back into the Chamfer toolpath. So now what we need to do is select a tool from the tool database. So we're going to go to the bullnose section, and here we're going to look at using a 1/4 inch bullnose. Press select and that will apply that here. So now in the Chamfer Dimensions section, you can see that we are now able to enter in an angle in this field. Let's say we wanted to create a 45-degree chamfer here. Just simply type in the angle that you want, and then we can specify the width or the cut depth. So again, let's just go for a cut depth that's the same as our material. So here we're going to go with a cut depth of 1/2 inch in there. So notice that now that I've entered in that cut depth, that our maximum cut depth is now showing as 0.5366. And so the reason that this is more than the 1/2 inch cut depth is because we are using a rounded tool. And where the centre of the tool touches the 1/2 inch cut depth at the bottom of the chamfer, we will be left with a cusp. And so the software knows to drive the tool down a little deeper at the same angle to create a nice clean chamfer at the 1/2 inch cut. So then we're going to make this chamfer on the outside going upwards. Okay, so we're going out and up, so up from the vector, going on the outside of the vector as well. You can give that a name, so again we'll just go with the default name here, chamfer 3, and then we can simply go ahead and press calculate. It's going to tell us that we're going to cut through. We're well aware of that, so we're just going to accept that. Okay, so here we can see all of the different passes that the tool is going to take to actually cut this out. So let's just go ahead and preview that toolpath and see how that looks. Okay, so as it stands, the chamfer isn't exactly smooth, and this is all down to the actual pass depth of the tool itself. So if we look at decreasing the pass depth, then we should get a much smoother chamfer there. So if we double click on that toolpath, we can just use the edit option here, and here we can just alter the pass depth. Let's just decrease that to 0.025 in this case. OK that, press calculate, and then we can just see how this looks. If we preview that, you can see now we're getting a much cleaner chamfer there because the actual pass depth is much tighter. And obviously we could do a lot better than that as well. So always check your pass depths on when you're using a round tool to create your chamfers. It's also worth noting here that you are unable to create clearance passes in the Chamfer toolpath. And if this is something that you wanted to do, then you'd be better off using the moulding toolpath. To learn how to use the moulding toolpath, then please refer to the moulding toolpath guide, which you can find in the related videos section for this tutorial. Let's have a look at another example. So we'll close out of the preview toolpaths form. We're going to select this vector here. We're going to go back into the Chamfer Toolpath. So this time we're going to look at using a different tool. So we'll go in the tool database using the select option here. Let's have a look at using an 1/8 inch ball nose. Press select there. Then we'll go into edit just to check over the pass depth. Okay, so I'm happy with that pass depth. So we'll go ahead and press OK. And we can specify our chamfer dimensions. So this time I would like to change the angle. We'll make that 30 degrees this time. And all of the examples I've shown before, we've gone by the cut depth. Now we're actually going to go by the width this time, because let's say that I want a chamfer that is exactly 0.15 inches wide. I can do that. I can just do that by typing that in. And again, as I've spoke about before, the alternate field will also update. So we know that we're going to get a cut depth of 0.2598 with a max cut depth of 0.2911. Then we need to choose how we want our chamfer to be created. So we want that on the outside of the vector, or we want that sloping downwards. So we're going from the vector going down. Okay, and you can see that displayed there in the 2D view as well. So chamfer 4 is okay. We'll go ahead and calculate that. So here is our toolpath, and then we could go and preview that toolpath. And so here you can see again, we've got a nice clean chamfer there, happy with what we've got there. And then I can go ahead and create a profile pass around the outside of that chamfer. Now, because I know the width that I specified for the width of the chamfer is 0.15, I can just jump straight over into our offset vector tool and then say we want to create an offset going outwards of 0.15, offset that out, select that new vector, we'll switch back over to the Toolpaths tab, we'll go into the Profile Toolpath, we'll cut all the way through our material on the outside, and we can go ahead and preview that material, and we can see that we now have a chamfer that has a little bit of flat height underneath it. Okay, perfect. Let's just put that back in Z. So now let's have a look at an example where we can use the Chamfer Toolpath to create countersunk holes. So let's just go ahead and we'll just save this file. And then we can go to File, Close, and then we're going to open an existing file. We're going to look at Chamfer Toolpath Guide Example 2. We can open that up. So let's just tile our windows and then we'll switch over to the Toolpaths tab. So here I have a door sign in the making. So we have a vcarve toolpath for the actual number. Okay, so there's our number vcarved there. And then we also have a chamfer toolpath for a decorative edge. So we could go ahead and preview that toolpath so you can see what that looks like. Okay, so here is our decorative edge, we've got our number. Now I want to create hanging holes for my sign, where I want the holes countersunk to ensure that the screws don't stick out above the material. So this is where I could use the chamfer toolpath to create the countersunk holes. So you can see here that I have two vectors, and these represent the countersunk hole, both at a diameter of 1/4 of an inch, so it's just a little larger than the screw head that I plan to use. So first off, it's always best practice to clear out the holes first. So you can see over here, I already have a toolpath here, so if we just preview that, so we're just drilling in those holes to basically clear that out in the center of those circles. So all we need to do now is actually create the chamfer using these vectors here. So with those selected, let's close out. We're going to go into the chamfer toolpath. So let's go and select a V-bit from our tool database. So here we're going to go with the 60° 1/4 inch V-bit. We could go ahead and press select. Okay, now I told you that the diameter of my circles is 1/4 of an inch. So we're going to put in a width value of 1/8 of an inch in there. Now, as we are creating a countersunk hole, we can actually alter the tool settings to cut this out, where it will make just a single plunge for very efficient countersinking. This is only applicable to V-bit tools, so you want to alter the pass depth so it's slightly larger than the maximum cut depth, which here we've got as 0.2165. So if we go to the edit options here, and if we just edit the pass depth so that it's say 0.217, and then go ahead and then press OK, that should ensure that we are able to machine this in one single pass. So we want to machine this on the inside where we're sloping downwards, okay? And we could go ahead and press calculate. And then you can take a look, you can see we've just got one single plunge there, and then we could go ahead and preview that. And there you can see we've got really nice countersunk chamfered holes there. So now that we've looked at all of the options to create a chamfer, let's now look at some of the further options within the form. So we're just going to close out of here, and we're just going to save this file to the project folder. We're just going to close out. I'm just going to jump back in to the first example. Let's switch over to the Toolpaths tab, and then we're just going to open up the Chamfer Toolpath. Let's say I wanted to create the same chamfer on all 4 of these vectors, but I also want the software to calculate the toolpath based on my order of selection. All I need to do is use this option here to use vector selection order, and the software will calculate my toolpath based on the order that I selected the vectors in. So for example, let's say we wanted to start here, I'd select that, then I'd press Shift to select the next one, Shift to select this one, and then Shift to select that one. So we've gone from here to here to here to here. I could go ahead and calculate that, and we can see that that's respected that order here. And so if we just go ahead and preview that, you can see it's done that like so. Okay, so we'll just undo that, and then we'll just right click and we'll just delete this toolpath. Let's close out, let's go back into the Chamfer Toolpath, and then we'll look at the last option that we have within this form, and that is the ability to use the vector selector. Now this is the same selector that you will see in most of the toolpath forms. So if we click on that, you can see we've got the various options to have the toolpath select our vectors automatically based on the layer information. Now I'm not going to go into this, but this is covered in a number of other tutorials. So that completes this in-depth guide to the Chamfer Toolpath. Thank you for watching.